Yeah, good morning, all of you. We are going to start the merge operations today, how it will work. So, last class, even we have discussed a lot on the persistency storage and even persistency storage also, how the data will be stored between data and log volumes, and how log volumes will be updated, how the data volumes will be updated. So today, related to that, we are going to discuss merge operations. So even the restart procedure we discussed, during the restart, what will happen? So all these things last class we have discussed. Lazy restart and the complete startup process. What are the sequence of steps while restarting of HANA system? So all these things you need to remember, guys. Simply, if you leave the concept, it won't be useful. Okay, if you listen and if you leave the concept, it won't be useful. I'm sure these are the questions they will ask you in the interview. Okay, so continuation to the last session, guys. This is what we stopped. Next session, the memory usage. This is completely new to HANA. Earlier, however, it was getting updated in ECC or any other databases, and to HANA, it is entirely different, guys. So in HANA, only there are two concepts here: HANA memory pool, HANA used memory. There are two things. But in the old sessions, the memory concept will work in a different way. We have role area, we have extended area, we have paging area, heap memory. The concept itself, it is different. But here we may see HANA memory pool, that is a virtual memory, and HANA used memory. So in the HANA memory pool, right from the code and stack means for the system usage, some of the space will be dedicated. For the system usage, to execute the code, whether it is a stored procedure, whether it is a SQL command, or any of the other commands user is using to load the code or to execute the code, what exactly needed will be part of code and stack page. So there is a dedicated memory for the code and stack. In the simple terms to say, even in the other databases, even till ECC before HANA, your RAM, if you are using 1 TB of RAM, 1 TB means 1024 MB, 1024 GB it has to show. But earlier we know, we used to see somewhere around 800 or 850. We don't see the complete RAM. So the missing space is used for the code and stack. But in HANA 1024, in the sense 1024 it will show you, and 10% of space will be dedicated for the code and stack. Concept is almost similar, but only the difference here is that was kind of a missing space in other databases and other memory concepts, but in HANA it is dedicated for the code and stack. There we used to say system side transactions to run, to load the system, to load the DLLs, to load the executables. Some of the RAM will be dedicated. Even that space you will get it from the RAM, that space will get it from the hard disk also. So even hard disk, if you get 500 GB, it won't show you. It will show you somewhere around 490 or 490, 450, 440, something like that. So the missing space, the 10% of space will be used for the DLLs to load, executables to load, system side transactions to run. The same way in HANA, but the missing space is not a missing space here. It is the dedicated space for code and stack. Got it?
Yes, sir.
Okay. Any questions, guys, on this? Any questions on this, all of you?
No,
Okay.
sir.
Okay, done. Next, system tables, row tables, and column tables. System tables, row tables, and column tables. These are the other three tables to load. Some of the RAM will be dedicated here. So, what is system table? System tables, in the sense, there are some default tables for HANA system. To load these tables, for the system side transactions to run, to load the HANA Studio, to load the content of HANA system, and to load HANA cockpit, what exactly you have it, and startup related, like a tenant related, system DB related, to load everything, we have some system tables. Those system tables are loaded in the sense your HANA system is working. If the tables are not loaded, then we are not starting, we are not loading any tables into a HANA memory pool, but automatically these tables will be loaded with the execution of start command. Once you start the HANA system, to load the system tables, some of the space will be dedicated. Even this is 10% of your existing RAM. And row tables, as already we know, the combination is 5%, 5 to 10% to row tables, and the rest 90% will be column tables. So the table data to load, if 50% of your RAM is dedicated, in the 50%, 90% will be dedicated for the column tables. Rest 10% will be allotted to row tables. So that means 10% for the code stack, 10% for the system tables, 10% for the row tables, and the left out space can be assigned to the column tables. So in the memory pool, on an average, 50% of memory is assigned to column tables and row tables to load, and system tables and code and stack page. So in the simple terms, table data to load, this will be load, this will be assigned, and another 20 to 30% will be there for the database management system, for monitoring, to run the reports, to do the configurations, and all these things. Another 20 to 30% will be assigned. So during the installation, in the last screen, or from the last, before 2-3 screens, you will get the memory allocation, how much you want to give it for database management, column tables, row storage. The calculations 10% for the all the tables, 20 to 30% for the database management will be always there. Rest 30% will be empty always. It will be empty always, that is the allocated memory pool. This will be free always. So during the installation, maximum memory allocation, if you select, there is no free memory available. So that means 100% of memory pool will be used by the database management, column tables, row tables, system tables, and code and stack. So if you don't select maximum allocated pool, if you don't select the maximum allocation of memory, then 30% will be unused. That means if you use 1 TB RAM, 1 TB it won't show you in the system. So it will only 700 GB will be used by the system. Rest of the 300 GB will be unallocated. So whenever the space is exhausted, if you get any space issues, that allocated, like unallocated space, the raw space will be used by either database management, either column tables, either row tables or system tables, and code and stack. So till the database management is the space, we can call it as the used memory, and that is the unused memory. Got it?
Yes, sir.
Next, are you clear, guys, all of you? Any questions on this? Even in the certification interviews, last week I have given one HANA interview. So I have given for my job. They asked so many questions on this, but I cracked them. Okay, so even they don't know like how the DB management space allocation will work, what are the parameters. But so that's why even in the certification, HANA memory pool related, HANA used memory, and the used memory, what are the components you have it, and what is code and stack. Like this, you will get a lot of questions in certification as well. So HANA takes 16, I wrote last year, 17, mostly this week or next week I'll complete. Getting all of you?
Yes, sir.
Okay, good. Next, see this, guys. Continuation to the last diagram. Your RAM, that is the physical memory. As already told you, in that 70% will be utilized for HANA. In the 70%, in the 700 GB, 10% will be used for the operating system and other programs to load, and rest 70%, 10% means almost 770 GB. Rest 630 GB will be used for HANA. So whatever the memory we are using for HANA system is a resident memory. Out of 1 TB, we are using only 700 GB, means 700 GB is the resident memory. 700 GB is the resident memory, and the total memory is the physical memory. Free space never calculated as a resident memory. It's not like other databases. Other databases, resident memory means the complete memory, what is assigned here. And it is physical memory and resident memory, there is no difference. But in HANA system, out of 100% of RAM, physical memory, how much is assigned to HANA is the resident memory. And rest of the space will be unallocated, and that will be used by the any of the component need more space, either row tables, column tables, database management, or anything. It can be called as an unallocated space. In the other databases, this can be called as a heap memory, private memory. There are different terms will be used. So slightly the terminology is different, but the concept is same. There is no change in the concept. But the way the HANA database is utilizing the RAM, utilizing the physical memory is slightly different. Got it, guys?
Sir, one doubt.
Yep, go ahead.
You said that this rows and columns uses unallocated memory.
No, I never said. Rows and columns will use the RAM which is assigned to HANA system. Whenever that space is exhausted, whenever that percentage of space is exhausted, some of the unallocated space will be assigned here if you enable the auto extension. If you don't enable the auto extension, unallocated space will be unallocated. If you enable the auto extension of the row tables or column tables, then once 80% is done, you will get alerts. yellow color alerts, red color alerts, you will get it. Then if you don't look into it, then if you enable the auto extension, automatically how much tables, how much space you want it, that will be assigned from the unallocated space.
Okay, that is the remaining 20% from where it is
Remaining
getting
20 or
assigned.
30%, approximately 30%, not 20.
So 70% is for SAP HANA and 10% is for OS and other programs.
Exactly.
And 20% will be the unallocated segment.
Yes,
Okay.
that's correct. And this is not exactly a standard calculation, guys. Some companies 50% they will keep it at unallocated, 50% only they will use it. Getting? So it is purely up to you. Even if you want to reduce the round trips on the database, then obviously you need to keep 50% of unallocated space like that. So based on the calculations, based on the memory usage, you need to increase the HANA resident memory. So resident memory will start with the less, and quarterly or half yearly will analyze the system environment. And if you are facing any problem, then resident memory will be increased. Resident memory is increased in the sense we don't add the new RAM. From the unallocated space, some of the space will be allotted to resident memory from the free memory. Clear now?
Good, sir. And this round trip, you said that is a when we make a request, and from the time the request goes and request that response comes, that is the only
Exactly.
this is round.
So when
Okay.
you are requesting something from the DB, if the resident memory is less, you will get a fast reply. If the memory is high, it has to read each and every table in the HANA system. That's why we'll start with the less, and eventually based on the requirement, it will be increased. Got it, guys? Getting all of you. Yeah, see this. So for all your questions, you will get the answer here. So for code and stack, the space allotted and the space utilization, it won't exceed. So always that is for the system side usage. Obviously, the 5% or 10%, how much you are assigned, that will be there and that will be taken care. So you don't get the space, the code and stack page is exhausted, the memory is exhausted, or we may need more space on the code and stack, because code and stack, how much space is needed to load the system type tables and everything, that much space will be allotted. So automatically system will take how much is needed to load the HANA code and stack. So that means HANA system is the combination of hundreds and thousands of programs. Those programs are developed earlier. If you are working with HANA, means those programs should be loaded. To load the programs, how much space is needed, that is constant. We should not change it. On top of that, all the tables to load. So system tables, row tables, and column tables, there is a dedicated memory, and that memory sometimes you may need more space also. So that you will get it from the used memory, and the total space what you used by all the tables can be called as a resident memory. So used memory is the combination of database management system. The curve above all the tables is the database management system. So database management system also, we don't use the consistent memory. Based on the free memory, based on the usage, based on the issues we are facing, the database management memory will be used. So that can be called as a resident memory. On top of that, we'll keep the used memory high watermark. That means above the resident memory, below the physical memory, whatever the memory is allocated, the maximum utilization of the memory, if you keep 90%, in that 90%, above the resident memory is the virtual memory. So that virtual memory can be used whenever the database needed more space, whenever all the tables needed more space, that resident memory will be increased to another 5% or 10%. But maximum limit is still allocation limit only. It won't utilize the complete 100% also. So during the HANA DB installation, if you keep maximum allocation of the DB, maximum allocation means it will take 90 to 95%, not more than that. 100% it won't take it. So that 90 to 95% will be utilized for complete HANA. But HANA in the sense, in that you have a virtual memory, in that you have a resident memory. Resident memory exactly used by HANA system. The virtual memory is not used by HANA system, but it is dedicated for HANA system. Yes, next, how the data will write into HANA system. So, as already we know, as already we discussed, main storage and delta storage. There are two types of storage, guys. Main storage and data storage. So, the main storage and delta storage will happen in HANA. Delta storage, like whenever the user is trying to do something, whenever the user is writing something in the system, for example, you are creating a user, guys. You opened SU0, simple example I am giving, or you are performing a client copy, or when you are doing some configuration in the HANA system, when you are doing some configuration in the HANA system. So once you started the transaction, that means user creation, you can take it in the simple terms. When you are creating a user, you fill the username as Ramesh and you fill the password, address data, logon data, however you are filling. The data will update into delta storage. That means whatever you are updating, whatever you are writing in the system will be stored into main memory, that is in the column storage. Only the row storage contains the username and the password, or the primary key, secondary key, whatever you have, it will be get updated. So in the main memory, in the column tables, the write operation will run, write operation will work. Whatever you are writing there, the data will be get updated into delta storage. From the delta storage, the data will be processed. And even what, see, until you save the last button, like once you fill everything, you will click on save button in the last. By the time the data will be processed, compressed, and for the reading purpose, how users will expect, it will be optimized and it will be stored into main storage. Delta storage, main storage contains the same information, but only the difference here is, just like if you go to the bank, guys, bank counters will be there. Whatever the money is coming to the bank today, till evening it will be there in the counters. By evening, they will separate all 500 notes, 1000 notes, 10,000, 2000 notes. They will separate everything and they will process everything. They will bundle it and they will store it into the lockers. So if you calculate everything in the counters, whatever you have and whatever is there in the lockers, it is same. But the difference here is delta storage is right optimized. Like the customer is coming to the bank, he can deposit the money, he can take the money, withdraw the money. That is the delta storage. Main storage means it's kind of a locker. That means every 2 hours or every 3 hours, every 4 hours, the data will be processed in all the counters and it will be sent to lockers. That is the main storage. Why we need to process this data? Like lockers, however, already the cash counters, they have processed the money. Then why again we need to calculate, why we need to bundle it? Why? Because tomorrow if someone is needed, even Reserve Bank, they need this data. Again, we don't want to calculate it. So that's why they will bundle it and they will separate it. So this is exactly the way how delta storage will work and main storage will work. Are you getting, guys? You got the difference?
Yes.
All of you. Just a small example I have given to understand better. You got the difference between delta storage and main storage, all of you?
Sir, once again, explain it, sir. I was there. I wasn't there in other activity, other mail. I was to write it, so I missed that part, sir.
Oh, okay. See, delta storage is the temporary storage in the column tables. Temporary storage means these are all right optimized space. So all the cash counters in the bank, you have 10 cash counters, 10 cash counters. Like however the customers are coming to the bank, they will take the money, they will keep it into the counting machine and they will throw it there in the down and they will update in the system. So that is right optimized. That is good for right optimized. And they don't wait until they bundle the notes and until they update into the lockers and everything, they don't wait. So that is not the read optimized. Why they want to wait until like what Reserve Bank can understand and all these things? They don't need it. What they need is the bank a cashier has to take the money, he has to give the receipt. Later you can process that amount. So by end of the day, whatever the money we got it today from different customers, each and every cash counters, they will calculate all the money. They will separate 500 notes separately, 1000 notes, 2000 notes separately, and they will bundle it and they will update in the system by end of the day. Why? Because tomorrow, if the manager wants to check how much money we got it today, how much went out, and this read optimized main storage will be helpful. So that is how the bank cashiers will process the money and they will update everything into the lockers. So your cash counters is the example for the delta storage and lockers is the example for the main storage. For temporary purpose, delta storage will be used. That is exactly needed for the write optimized operations. And read optimized operations, main storage is needed. So tomorrow, if user is expecting, user is trying to process something. So if the data is not processed, if the data is not processed and compressed, then you cannot get the data like how the user is expecting. For that reason, the main memory, especially the column storage, not the row storage. Row storage, there is no more delta and main storage. This is needed only in the column tables. Because of this delta and main storage separation, we have achieved high performance, high write performance in the HANA system. If you don't have this, and it is very hard for the users, if you want to get something from the column storage, again it has to read each and everything. So if the delta is not, if the data is not processed in the columns, obviously it will occupy more space. Getting, guys? It's just an example. So your bank is not at all following any processing the amount in the day, end of the day. So however the money you got it in the boxes, you want to keep it in the lockers. So it will occupy more space. If the amount is processed, compressed and calculated, then you may need less space in the storage, that is in the main storage. Are you getting, guys?
Sir, one doubt. This delta storage that we is it a physical space in the database, or just it is by concept wise it is like
We are
this?
talking about HANA memory, that is the main memory, that is the temporary memory.
Okay.
Physical storage
sir.
is always a physical storage.
Mm-hmm.
Got it?
Yes, sir.
The
So
same structure.
once the system restarts, that restart, then that virtual memory is removed, and once again there will be one sector delta storage will be created.
Yes, yes,
Okay.
that's correct. So that's why in HANA, see, you are taking lot of time to maintain delta storage, main storage. If the system is restarted, everything is going away. So then what is the point of using all these concepts? For that reason, in HANA, high available environment we need to set up. If one is down, immediately another node will come into picture. So we never face the problem like your node A is down or node B is down. Always your request will be processed in the main memory itself without contacting the physical storage. It will be processed from the main memory itself. So
sir.
because of this storage separation, 60 to 80% of data, that is compression rate is 18% of space, we can recover it with the help of this separation, and it is highly recommended for write operations, guys. So because of this delta storage, write operations are optimized. That means database never feel overloaded, and user, they never feel the transaction is taking long time, because everything is getting stored into delta. For example, if you go to the bank, if the bank cashier, each and every note they are keeping in the like counting machine, they are bundling and they are taking lot of time to update in the system. Usually customer, they never feel comfortable. So when they have to do in the end of the day, or every 1 hour they will take 10 minutes break and they will calculate everything, and that money will be sent to lockers. So the delta operation also will work the same way. Are you getting, guys?
Yes, sir.
All of you. Did you get the concept, guys? The
Yes, sir.
difference between main and delta storage.
Yes, sir.
Okay. So delta merge, in the sense, this is the difference between delta storage and main storage. Delta storage is write optimized. Write operations, whatever you are writing, you are updating in the HANA DB, it will be updated into delta storage. And after that, every like if you mention the time like 1 hour, 2 hours or something like that, delta merge operation should run. Delta merge equal to 1 hour. Every 1 hour the delta merge operation will run. Delta merge, in the sense, move the changes from the delta storage to main storage is the delta merge operation. That means from the delta storage, whatever the transactions are recorded today, everything will be processed, compressed, and it will update into the main storage as expected by the HANA DB, that is read operations, it will be get updated. So tomorrow, when you are requesting some data, I want to see the transaction details of last month. If the last month data is not updated properly, then if it is not read optimized, then obviously you may face a lot of time. Whatever you are storing in the HANA DB, if you don't get it properly tomorrow, then there is no point of using HANA DB. It's like other databases. That's why they have given this categorization called delta storage and main storage. So delta storage and main storage is asynchronous and delta storage is synchronous. And delta merge operation, you need to define the parameter when you want to go with the delta merge operation and how you want to do it. And there will be a background job for this. And this delta merge operation is asynchronous, guys. Asynchronous means based on the event you triggered and based on the event you define, the delta merge operation will run. Getting all of you?
Yes, sir.
Any questions?
In that diagram, delta merge one, this one.
Is this the one?
Sir, yes, sir.
Okay. See this carefully. See this carefully. Okay. There is a record, guys. There is a record. Before the merge operation happened, Ramesh is the existing employee in the organization, or one plant related, you are making some changes. Listen me carefully. One plant related, accounts payable, you are making some changes. Whatever you are making changes in the system, you are changing some company codes and you are changing some ledgers or whatever it is. It will be updated into delta. It will be updated into delta. And the same table, if anyone is accepting, for example, when you open one of the user record and when you are making changes, other users may open the same record, but they cannot able to make the changes. Why? Because this record is locked by the user one and he is trying to do some operations. So other user will get a read operation only. That means both the people can make the changes in the table, but only the first user can make the changes first. Until and unless the user come out of the screen, the second user cannot able to make the changes. So here the write operations will be done on the delta, and from the delta only the table will be get updated. So, but in the traditional SAP system, guys, you remember when you are working with the client administration, when I am working with the client administration, and when you try to open the client, you will get a message, client is locked by the user Ramesh. Until user committed the transaction, you should not touch the client administration. Is that correct, guys?
Yes, sir. Yes, sir.
But in HANA, how it will work, you know, when user open the client administration, the write operations will happen in the delta, not on the physical file, not on the main storage. That means what will happen? This file will be read by anyone in the team. That means at a time, 10 people are accessing the same file for the same update. It will be possible. But from the delta, only one person can update into the main storage. The delta merge operation in the first come first serve basis, delta merge operation will be done. So that means here, however the transactions are happening on the screen, the locking mechanism is replaced with the delta merge operation here. That means one table can be accessed by thousands of people at the same time. But whatever you are making changes, the changes will be recorded in the delta storage. From the delta storage, in the first come first serve basis, and the time interval what you have given, based on the timestamp, a delta merge operation will run and the main storage will be get updated. So now, for example, Ramesh phone number, Gautam is changing and he changed the number. After Gautam, someone has changed. After someone, like that 10 people are changing Ramesh phone number, 10 different numbers, they are updating. 10 different numbers will be get updated in the delta storage. No one face, the table is locked by so and so. But all the 10 records in the first come first serve basis, 10 versions will be created. 10 different versions will be created. During the merge operation, it will verify based on the timestamp. 10 operations, 10 records will be updated in the main storage. User, whatever they need tomorrow, for example, Gautam changed the number. Tomorrow when he retrieved the data, he should not get the other information. So whatever is updated by Gautam, he will get the same information. But if you check the timestamp, whatever is updated in the last, it will be updated by the delta merge operation. That means each and every user, whatever is working on the HANA system, there will be a version created, and each and every delta operation, delta storage, each write operation, there is one main storage will be created. Each delta storage, one main storage will be created. Are you getting, guys?
Sir, one doubt here I'm having.
No, I'm coming there. I can understand now. What will be your doubt? So, for example, the same table, 10 times you made the changes on the table. Change 1, change 2, change 3, 4, 5, 6, 7, 8, 9, and 10. For read operations, the last change will be available, not the old changes. That means when user is retrieving the information, user can get only the most recently processed data. Most recently processed data, not least recently processed data. Most recently processed data in the sense, 10th version, the last change will be available to the users for the read operations. That is after merge. During merge, if you see, 10 write operations, if you made it, 10 write operations will be available during the merge operation. But after merge, the last change will be available in the main storage, not all. All will be there, but for read operations, only the last change will be available, not the old changes. That is the delta merge process, guys. Now, Gautam, you can ask me now.
Got it, sir. It is answered now.
So, this is a usual question everyone will ask in the batches. Okay, but versions will be created, guys. But if Gautam got the doubt, like he has given a different number and what is this number, then he can open multiple versions there. He can request version 1, 2, 3, 4, 5, and you can get the data. Got it?
Sir.
That is the delta merge operation, guys. So read this, you will come to know. Read this, and while reading, you will get a lot of doubts, guys. These doubts will be discussed tomorrow if it is possible. Next, merge types. So there are two types of merge, guys. The merge operation will be done two types. One is automatic system process. If you define the merge operation every 1 hour, the merge dog, there is a component called merge dog. The merge dog will take care of the merge operations, and the merge dog will take care of auto merging and critical merging. Critical merging in the sense on-demanded merging. And auto merging means based on the time, if you specify 1 hour, every 1 hour, the merge operation will run. Clear now, all of you?
Yes, sir.
And there is user specific merge operation, user or application specific merge operation. So today I have executed one critical transaction and I don't have the time till 1 hour to update in the main storage. Why? Because this is very critical for us. Then we can go for the user and task specific merge operation. Then immediately you can start the delta merge operation. So the delta merge operation is hard, forced, smart, and memory. Hard in the sense, like you can define how you want to merge the data into main storage. Forced in the sense, hard and forced is almost same, and there is no difference here. Hard in the sense, forcibly, if any other delta operation is running, if you go with the hard, it will wait until the existing delta merge operation is completed. But forced in the sense, it won't wait until the delta merge operation completes. Your merge operation will be get executed on priority. Next, smart delta merge operation in the sense, you can give the hint also, not only to run either hard or forced. You can give, okay, delta merge operation today, I want to update this record after existing delta merge operation is completed, or after today's night 10:30 backup will run. After backup, I want to run the delta merge operation. Why? Because these records will be get affected by the time. So like that, the smart merge operation also we can do it. And last, memory optimized. Memory optimized in the sense, if you have any memory bottlenecks, and what exactly out of all the right operations, what kind of delta merge you want to run, what are the right operations you want to take care, and you want to merge it into the DB, that you can define. So this is purely a user specific or application specific. But if you go with the automatic system process, every 1 hour if you specify, that 1 hour it will run. So there is a merge dog, auto merge dog, that will take care of it. Clear enough?
Yes, sir.
So here usually 24 hours they will keep it for the merge operation. And if you want to reduce it, if you want to increase it, there are some parameters, as I told you just now. You use these parameters to make the changes, guys. This is about your merge operations. So now see the questions which I asked you just now. These questions straight away, try to refer the questions and get the answers. And I'm sure these questions will be asked in the interviews, guys. Clear now? This is about your architecture. We are done with the architecture. We have done the architecture part. Installation we have not seen, but tomorrow we are going to do the installation, then post installation also we can complete.